Okay. So this is the unit number 1. We are discussing the architecture of Intel 8085. This is the first topic of your syllabus is there. So if no one is present, please tell your friends to join this session because this is the starting of your microcontroller, which is the first topic of this microcontroller. Means microcontroller subject is there. So if you understand this topic very well, there is every similar topics in 805, only some differences there. Just like our languages there, C and C, only difference is there. So please, if anybody is up, not attending the class, please tell them to join this. This is the objective of this topic is there. What is the objective? You must do the pin diagram and architecture of 8051 to get the familiar working of the 8085. Means we are discussing the 8085 8085 in detail. In 8085, we are discussing the what is the architecture of 8085, what is the pin diagram of 8085, what are the registers present in 8085, and what are the instructions are there, and you have to see the program is there. So this is your syllabus in your university syllabus. These are the topics are present in your syllabus. First topic is your first is architecture of 8085. Sorry, features of 8085. Features means you can see as the characteristics of the 8085. What are the characteristics of the 8085? Then you are discussing the architecture. Architecture means what are the registers are present, how registers are work, what is the database, what is the address bus, then how it works is there. You are discussing in unit this architecture. Then functions of pin diagram, how many pins IC is there, because processor is the IC or 8085 is IC. IC means you know that what is meant by the IC. Integrated circuits are there. In integrated circuits, how many pins of this integrated circuit is 8085 there. We're discussing the each and every pin regarding this pin diagram is there. Then these are the architecture part is there. ALU, instruction registers, timing and control diagram, general purpose register, data bus, address bus, demultiplexing means what? What is multiplexing? What is meant by the address bus? What is meant by the data bus? See, these are the points we can say ALU, then address bus, database. These are similar points present in your 8051. If you understand what is meant by the database, what is meant by the address bus, the same point is repeat in 8051 is there. Then what is meant by the timing diagram, what is meant by the instruction register, same is present in your 8051 is there. So only a repeat is there in 8051. Then this control signals are there. Same control signals are present in 8051. Some one or two are increases or different is there. Then instruction set are different from 8051 and 8085, but meaning is the same. So this is the syllabus of your first unit is there. So one by one we are discussing all the syllabus. So first go to the next point or go to the topic or syllabus. Just read what you know that. What are the points you must know that? So first point is the bit. First point is the bit. I think everybody know that bit, but just revise all these things. This is the bit. It is called the bit means what? In your binary system, this symbol is the bit is there. In binary system, two are there, 0 and 1. 0 and 1 is the called the binary is a numbering system. In numbering system, why? Because our microprocessor is understand only a binary system. So everybody know the binary system very well. Everybody know the binary system very well is there. Binary system means there are two bits, 0 and 1 are the two numbers are there. Okay. This 0 and 1, this is called the bit. 0 and 1 is called the bit is there. This is the bit. Byte means what? Byte means if you collect these 8 bits together, if you collect this 8 bit together, then this is called the byte is there. If you collect 8 bits together, this is called the bytes are there. And nibble means what? You have to collect the 4 bits for 8 bit for the byte and 4 bit for the nibble. 8 bit for the byte and 4 bit for the nibble is there. So this is the bit and byte. This is the binary system because our all microprocessor is working in the binary system. So you must the byte is called binary. By means what? Two numbers are present in the binary system there. If you collect the 8 numbers, such a number, this is called the byte, and if you collect the 4, this is called the nibble is there. Okay. So this is the, if you know that, everybody know that because it is there. The next is called the program. See, in microprocessor, I'm telling that in previous we are setting the instruction set. Okay, instruction sets are there. You have to write down the program means what? If you arrange one program, suppose you arrange any program is there. Suppose program means what? You have to arrange, suppose at the 10 p.m. there is a inauguration is there. 10:30 there is a speech of your chief guest is there. Then 10:45 chief then speech of your students is there. This is the program, and one by one these points will be executed. And after that, if you successfully execute all these points, then you can say program is successfully run is there. Same is there in our controller system. Program means what? These are the instructions we are discussing in discussing 8085. If this instruction you write down the instruction step by step, and all these instructions are executed properly, and you get the proper result which you want, then this is called the program is there. Means you're writing the instruction step by step for your output is there. Then this writing the instruction is called the program is there. And number of programs you have to collect together, this is called the software. Number of system is number of programs you have to collect together, this is called the software. So you know that what type of softwares are there. I'm not going to the application software, operating systems are there. Then but this software means instructions write down together, this is called the program. Number of programs come to this is called the software. These are number system, just you know that, but just for discussing these are the types of this is the decimal system we are using here. The number should contain 0 to 9. The only 0 to 9 you have to know the numbers, and you have to arrange this number in such a way that you will get the big number is there. In binary system there is a 0 and 1 is the number is present. Octal system there is 0, 7 is there, and for hex system 0 to 9 and A to F is there. So this is the numbering system. For your information, you must know that all the points are we must know. Main is the this hex system and binary system. You must know that this system is a hex system and binary systems are there. Then logical operations are there. Logical operations are and, or, and not is there. The logical operations are what were called logical operation at the in your in your microcontroller, microprocessor or microcontroller. There is one unit is called the ALU. There is one unit is the ALU, and in that unit you are working with the arithmetic. A means arithmetic, L means logic. A means arithmetic and L means logic, and this is the U means unit. You have to working with the arithmetic logic. Arithmetic instruction means addition, subtraction, multiplication, and division. And logical units means what? And, or, not are the logical units. Are logical means what? If two conditions are true, then you will get the output. Just your C program, you have to use if A is greater than B, then execute the next instruction. If it's not, then execute the next instruction. This is the logical operations we have to done in your microprocessor as that. Okay. So what is meant by the microprocessor? See, microprocessor is only a chip. See, microprocessor is only a chip. It is having a some memory to store the data. It is having a some memory, not big memory, but it is having a memory you have to store it. But you can't connect, means you can't connect the keyboard to them, means it is only a chip. And for working purpose, you have to connect this input device. You have to connect this input device, or you can say it is the output device to them. This is the memory. You can internal memory present. Microprocessor is contain internal memory at CPU, but you require the external memory there. Just like our brain is our microprocessor. Brain is our microprocessor. Hands and legs are the input connected to them. Then output you have to give the output to them. So main is the processor is don't have input and output. See, this is the main difference between microcontroller and microprocessor. Processor is only chip. Processor is only a chip. You have to connect the input devices and output devices to the chip is there. See, in your computer is contain a processor is there. Pentium 1, Pentium 2, Pentium. That is a processor. If you remove this processor, you can't work on that. You have to connect the processor in motherboard, and you have to connect the peripherals to them. Means which peripherals you have to connect? You have to connect the keyboard, you have to connect the mouse, you have to connect the CPU for the output device. For input device, keyboard is there, mouse is the input device, and then all is working through the instructions given by the processor to that keyboard or mouse, and then working will be done. So processor is a device we don't have input and output device. Processor is a chip, or you can say the processor is don't have input and output device. It having a memory but less memory. You have to connect the extra memory to them by using a by using the pins which is having with the processor. When you're working with the pins, then we are discussing all the points related to the microprocessor. Okay, so this is the microprocessor is there. So this is the basic uh, this is the basic diagram of the microprocessor. See, this is the basic diagram of the microprocessor. Input device, This is the microprocessor, this is the memory, and this is the output device. So you have to connect the input and output device to the microprocessor. Next is the evolution of the micro. Historical evolution is, see, here is the processor which is having the processor 4, 8, 80, 85, 86, then 88, 286, 386, 486, Pentium, Pentium Pro, Pentium 2, Pentium 3, Pentium 4 are there. Then year of introduction is there, where their introduction is there. Number of transistors are present in there. Initial speed of the 5 megahertz speed of that. Then how many address buses present on that, then what are the data buses present on that, and addressing memories are the clock. Addressing memory is, and you can store into the processor is there. I'm saying the processor is having the some memories there. So this is the microprocessor is there, is having a historical or number of transistors are present in there. For our purpose, we are discussing only one is there. See, this is the 8085 we are working. Year of introduction is 1976. Number of transistors are 6500. Initial speed is 3 megahertz or maybe 5 megahertz. Last lecture we are discussing the Kale software, and in that Kale software, the Atmel is created the 8085. They're having the frequency is 3 megahertz. This having the frequency is 3 megahertz. So you can say 3 megahertz or 5 megahertz are there. Then address bus is 16 bits, and this data bus is the 8 bit. And what are the address memories? 64 kilobyte is there. Address memory is 64 kilobytes. If there is an online examination, you must remember how many address bus, how many data bus, and 64. Since 8 bit is where 8 bit is there from, 8 bit is the size of your ALU. The size of ALU define this data bus is there. Size of this ALU is defined the data bus is there. So this is 68-bit data bus is there, and 64 is the addressing memory. So you are only remember this thing. Then difference are there. You can say properly this is 10-bit address bus. Then so the data bus is 4-bit, 8-bit, 8-bit. Then up to the Pentium is you are giving the 64-bit database is there. See, if number of database or size of the database will be increases, then speed of the processor will be increases. See, our ultimate aim is to, what is our ultimate aim is to increase the speed of your calculation is there. How can you increase the speed of the calculation? Lot of factors is required to increase the speed of your calculation is there, but one of that factor is the database is there. Database is one of the factor that you can increase the speed of your calculation is there. So this is a 64-bit, here is 8-bit. So 8-bit is the, if you want to do the calculation by using 8-bit processor, it's required more time as compared to the processor is having the 64-bit is there. So this is the, so then you go to the features are there. So it is very important features. If you understand the features very well, then whole controller or microprocessor will be understanding there. So what is the processor is there? Microprocessor is only a chip is there, and it is required to connect the external devices, maybe a input or output devices there. It don't have a more memory. It is having less address memory is there, and we have to require more memory. You have to connect the extra memory to the processor. Remember this thing. So because when you are going to the microcontroller, there is a difference between the microprocessor and microcontroller. Same difference is there. Okay, I will explain controller is very well. So first features, you must remember these features because a lot of online questions are on that features of 8085 there. So first feature of the 8085 is 8-bit microcontroller. Sorry, MPM is microprocessor. I'm saying why it is called 8-bit, because ALM is arithmetic logic unit is working up to the 8-bit. When our 8-bit is the microcontroller, then 8-bit is the ALU is there. Means all calculations, means addition, subtractions, multiplication are done into the 8-bit data is there. If I want to add two 16-bit data. If I want to add two 16-bit data is there, but it is not possible to add 16-bit directly. First, you have to send 8-bit, and then after 8-bit, the remaining 8-bit will be added there. So require time of suppose 1 sec. just I am saying not 1 second. If 1 second is required to calculation of the 8-bit addition, if I want to calculate the 16-bit addition, it require a 2 second is there. So for the calculation, the time will be increases, and if time increases, the processor will be less bit is there. So data bus or this 8-bit is the depending upon the ALM is for the calculation purpose is there. Okay, so size of your 8085 is 8-bit. You must remember at the time of the oral examination, everybody asks only a simple question to the students because you are from electrical students. So they ask the question, how much 8085 is the how many bit of the microprocessor. So you must remember the 8-bit. Why it is 8-bit? Because ALU is contain 8-bit. So he do the calculation is up to the 8-bit is there. At the time, it can't calculate the 16-bit directly. Only it is working with the 8-bit processor. This is the first. Then next point of the feature is there. Next point of the feature is data bus is 8-bit and address bus is 16-bit. Data bus is 8-bit and our address bus is 16-bit. What is meant by the data bus? What is meant by the address bus we are discussing? Data bus means if I am writing, suppose I want to add two numbers. If I am writing two numbers are there. Suppose I want to transfer 8 to the ALU. So this is the number. When this is the number when this is the data is there. This 8 data is transferred by using which bus? This is the data bus. It is transferred from the data bus. But this 8 is stored at location suppose 2001. You have transferred this 2001 is the what is this? This is the location. This is the location. At that location, this 8 will be at that location. This at that location, this 8 is stored. So this location is stored transferred by this 6 bits at 16-bit address. Okay, understood. So this 16-bit is address bus is transferred by this one. Okay, means 2001 is the location. At that location, this 8 is stored, and to that 8 is stored. So this 8 is transferred through this data bus, and this location is transferred to the address bus. So different address bus and data bus are present. We are discussing what is the multiplexing afterwards, but this address means what? The location where the value stored, it is transferred by the address bus, and the value is transferred by the data bus. Means data is transferred to the data bus, and address means location where data is stored, it is transferred to the address bus is there. Okay, and the operating frequency I am writing here is 3 megahertz, maybe 5 megahertz this is there, but here is the by default you can understand this is the 3 megahertz is the frequency is there. Okay, 3 megahertz frequency there, you remember this. Then another is address capacity. Address capacity of the device. Address capacity of the device. See how to calculate. It is very important part. How to calculate the address capacity of 8085. This question is asked at the time of the oral or at the time of your online examination also. This is very important. How to calculate the address capacity of the device? How to calculate address capacity of the device? See, it is calculated by using the size of the address bus. It is calculating the use of the size of the address bus. If size of the address bus is 16, then 2 raised to 16 is 64 KB is there. If you calculate by using calculator, you can get 64 something is there. The 64 KB is there. Understood? So address bus is the 16-bit. So you have to calculate the 16-bit by raised to 2 raised to 16 is there. If your address bus is 20-bit, then your capacity of your microprocessor is 2 raised to 20 is there, or maybe the value which is present is the address memory. So how to calculate the address of microprocessor microcontroller is there by calculated by using a 2 raised to the size of the address bus is there. So it is very important part. So you must remember, anybody ask if my processor is having the 20-bit address bus, so please calculate the capacity of your address is there. So you have to calculate by using 2 raised to 20 is there, 64 KB is the memory capacity of this. This is very important part. In microcontroller also you can calculate this way also. So this is a way to calculate the address capacity of the your microprocessor is there. Then you should remember how many transistors are there. They may ask the online examination, so you must remember 6200 transistors are required to construct the 80. See, it is the chip is there. You can see the black chip is there, or 40 pins are there. But inside this chip, there are 6,200 transistors are there. They are in such a way that the microprocessor will be manufactured is there. Okay. So this is very important part of this 8-bit data bus, 16-bit address bus, operating frequency. These frequencies are very important. We discussing at the time of the your programming purpose why this frequency is required, why what happen if frequency change of the processor, how the calculation speed of the processor or controller will be increased by changing the frequency of this. We'll discuss at the time of your programming. Okay, you just remember this is 3 megahertz is the frequency increase, the calculation should be increased. How it is increases, we are giving the timing timers and counters at the time of your 8051 is there. Okay, so this is the 6400 is there. The next point is your registers are there. So this is the registers. How many registers are present? So first register is accumulator. First registers are accumulator, and this accumulator is 8-bit. See, accumulator is the 8-bit register. I'm saying accumulator. You must remember this accumulator is a register where all the calculations. Accumulator is the register where all the calculations are done. Accumulator register all the calculations, maybe arithmetic, logic calculations, or addition, subtraction, multiplication are done by the accumulator. And also the result of addition, result of multiplication, result of division is stored directly into the by default into the accumulator. So you must remember this thing. All the arithmetic, logical, or the calculation results are present in or stored into the accumulator. You must remember for your online examination or maybe in your oral examination is there. So calculation A accumulator. So these are the register B, C. These are the general purpose register B, C, D, E, H. These are the registers are there. Are 8 bits are there. These are the 8 bits are there. So these 8-bit registers are there. If you arrange this, suppose B and C you have to add, then this BC is become a how many 16-bit register is there. If you arrange the D and E is there, it is a 16-bit register is there. And if you arrange H and L, this is the 16-bit. These are the pairs of the register for the 16-bit calculation is there. Because individual register B and C as the 8-bit register is there. If you collect these two registers and then 16-bit will be done is there. So this is the registers are there. B, C, D, E, H, L are the 8-bit registers. Okay. The next part is the flag register. We discuss flag register in next slide is there. Only remember flag registers are these flag registers are concerned with the calculation purpose for your addition, multiplication, division. For that calculation purpose, we have to use the flag register. For this calculation purpose, we have to use the flag registers are there. Okay, for this calculation purpose, we have to use the flag registers are there. Okay, you can understand. This is the flag registers are there. So we discussed. This is the 8-bit registers are there. What are the flags are there? Zero flag, carry flag, parity flag. How these flags are work? When this flag will be one, we'll discuss in later part is that. This is very important part in your theoretical examination. If your theory part theoretical exam will be there, then they ask the questions, explain the flag register of 8085. They will ask the question, explain the flag register 805. See, all the points which are discussing are same points in your 805. This 51 having accumulator is there, 51 is having the flag registers are there. Only some differences there at the time of 805. I will compare these differences there. So this is the flag register is there. We discuss in next slide is there, flag register is there. Next is the program counter. This is very important part your in programming. Program counter. See, program counter and stack pointer. Program counter and stack pointer. Those are the how many bits are there? These are the 16 bits. These are the 16 bits are there. This program counter is 16 bits and stack pointer is where they are used. Program counter is used in your program. Program counter is used in your program is there. Suppose here is a program counter is there. Here is the suppose one instruction is there. After this instruction is having a location. If instruction is having location, suppose 1 if it is having a location 0 0 0 1 is there, in that location this instruction is stored. So this location is stored into the program counter. So I'm discussing the where we have to store the location. For that purpose, this program counter. Program means what? our set of instruction is called the program is there, and counter means what? The set of instructions location is presented to the program counter is there. You have to increment the program counter, next instruction will be executed. So how can computer go to the, suppose I'm writing the execution is, suppose this instruction will be executed, after that second instruction is there, after that third instruction is there, how this sequence this instruction is done? Okay, suppose what I am doing, I am first for switch on the PC, what I am doing first, 230 volt will be start, after that I am start the CPU button, this is the second instruction. How does the third instruction is start your monitor button, then after that I am writing the fourth instructions, I am writing the password to the PCs there. Okay, so all these things I am done in your uh, compute in your instruction is there, and then program will be executed. So where my brain is store this instruction, first instruction is start the 230 volt. Okay, second instruction is start the button of the CPU, fourth instruction is start the button of your monitor is there, fourth instruction is there, write down the password to open the PCs there. So all four instructions are stored in memory location. Okay, but our brain is very good, so he can execute this. But you're writing the program. For that program, you give the instructions to the microprocessor, and the microprocessor must be execute each and instruction step by step. How can it fetch this next instruction? To fetch, you can remember this word is there, to fetch. To fetch means you have to take the next instruction is there. To fetch means you have to take the next. How would microprocessor fetch the next instruction? For that purpose, we have designed the program counter is there. Our brain is fetch the next instruction directly. How, we don't know, but it fetch the instruction, but we are designing the processor, so processor must know to fetch the next instruction. How we fetch the next instruction? So for that purpose, you have to store the program, you have to store the location of the program in your program counter is that. You have to store the location of the program in your program counter is there, and step by step this execution will be done. So program counter is store the locations of the next instruction. If you increase the program counter, the next instruction will come into your processor and execute that instruction, and you will get the output is there. So this is the program counter is there. This is very, very important part in your programming. You can do any programming in your language programming also, in your 805 processor, Arduino, ARM, or your C programming. Every program is having a pointer is there. So pointer is what? Pointer is store the instruction location of the next instruction in the program counter. If you increase the program counter, next instruction will pick. But this increment is done automatically in your controller, or you can say in your processor is there. Okay, so when you're programming, last lecture we are discussing the kill software is there. We have to execute the instruction step by step. Okay, step by step you have to use F11 is there for the step by step. I think F11 is you have to use for step by step instructions are there. So this is a program. This is a stack pointer. This stack pointer is used. See, every time when I am going to the oral examination, I am asking what is difference between stack pointer or program counter, or what is the function of the stack pointer is there. Okay, stack pointer is 16-bit register. What is the use of this stack pointer is there? This stack pointer is used at the time of the interrupt is there. If student understand what is the interrupt, then he can understand what is use of the stack pointer there. We're discussing the interrupt at the time of the stack pointer. You must only remember this thing. Stack pointer is used in your interrupt session. Stack pointer is used in your interrupt section. How will we discuss at the time of the interrupt? I am telling how this uh, stack pointer is used in the interrupt is there. We're discussing at the time of the interrupt is there. So this is another feature is there. See, see our address bus is A02. Just we are discussing multiplexing is there. See, address bus of your controller is, I don't have the pin that time. Okay, go to in your see on our 8085, the address bus are how many address buses? I am saying A, how many? A 16-bit address bus, A02, A15. Okay, This is the address bus A0 to A15. Understand? This is the address bus A0 to A15 is there. This is the address bus is there A0 to A15 is there. Okay. So this is the address bus is there. In that address bus, D A0 to A7. A0 to A7 means AD0 to AD7 is act as a data bus. See what I am saying. A0 815 is address bus. Data bus is what? Data bus is D0 to D7. Okay. This is the 8. This is the 8 and this is the 15. Okay. 15 at what? How much? 15 what is 23. 15 plus 8 is the 23 is there. Okay. 15 plus 8 is 23 is there. But if what I'm saying the 8085 the 40 pin IC is there. Okay, so for the data bus and address bus that we have to use it separately. So how many pins is required? Only 23 pins required only for the data bus and address bus. So what they are doing, they are multiplex the data bus and address bus. Okay, they are multiplex the data bus and address bus means what? At a time when you are using the data bus, then some part of the address bus it act as a data bus multiplexing. म्हणजे one person is doing the two work is there. Multiplex means one person is doing two work. Means what? When we are working with the data address data bus, so we have to AD0 to means from some part means 0 to A7. A0 to A7 it is act as a data bus. For what purpose? When we require to transfer the data to the ALU is there. Okay, understand. And when you have to transfer the address to the microprocessor, what we have to use? A0 to A15. We have to use A0 to A15. We have to use this A0 to A15. It is act as an address bus. Understood? So you have to multiplex a data bus and address bus. Okay, you have to multiplex a data bus and address bus. Means A0 to A15. We have to use for the data bus and address bus. So then again question is there, how can processor, we are the person who does, but how can processor is understand where we have to use the database and where we have to use the address bus is there. So for that purpose they have to use one pin your means apart from the 823 pins, or to increase the 8 pins extra, they are use one pin which is called the ALE. See, this is very important part. This is the ALE pin. Address same pin is present in 8051 also. ALE is, it is called, A means address, L means latch, E means enable. Address latch enable is the pin where we have to, if this pin is on means what? If this pin gives the plus 5 volt, or you can say it is having high is there. For that purpose, it is act as an address bus. We are discussing the timing diagram. If it is low, then it is act as a data bus. Means A0 to A0 to A15, A0 to A15. When this latch enable is high, then it is act as an address bus, and if it is low, it is act as a data bus. It is act as a data bus is there. So you must remember these things is there. Address bus and data bus. It is very important part because everybody asks what is the means what is the multiplexing in your 8085 is there. So what is the multiplexing is there? We have to use address bus as a data bus also. So for that purpose we have to use the AL is there. For that purpose we have to use the address latch enable is one pin present in your 8085. It is also present in your 8051. Then next is the power supply. Next is the power supply. You must remember power supply should be a 5 volt is there, not more than 5 volt is there. Then serial port is there. Next is the serial port is there. What is the serial port is there? Serial input data, serial output data. We're discussing the serial communication programming is there. This is two serial port is there. Then this is the clock generator. See, this clock generator is very important part at the when you are doing the programming is there. Clock generator. This programming for the program purpose you require the clocks are there. If clock size is increases, then means 5 megahertz, 8 megahertz, 10 megahertz, then your speed of the calculation will be increased. This is the on chip clock is there. So you must remember on chip का असतं, only on chip is clock is there. On chip memory नाही, on chip ADC नाही, because in 8051 on chip ADC is there. So then there is a 5 hardware interrupt. 5 hardware interrupt. Okay, interrupt means, so these are the interrupts are there. This is the first trap interrupt. This is non-maskable interrupt. Then this is RST 7.5, 6.5, 5.5, and interrupt request are. These are the maskable interrupts are there. So you must remember the interrupt means what and what is meant by the maskable and non-maskable. First, they ask question in your online examination: how many interrupts are present in your 8085? How many interrupts are present? These are the 5 interrupts are there. So they again your uh, online question is there: which interrupt is non-maskable? They give the some they give these 5 points are there. So which is non-maskable is the trap is non-maskable interrupt is there. Trap is the non-maskable interrupt is there. So this is the interrupts are there. So the question is what is meant by the interrupt. So question is what is meant by the interrupts are there. इन मराठी इंटरप्ट म्हणजे काय की आपण एखादं काम करत असताना ते काम थांबवण्यासाठी जे करतो त्याला ते इंटरप्ट करणे आपण त्याला काय करणे अडथळा निर्माण करणे यू कॅन से द ऑब्स्टॅकल टू द वर्किंग इज कॉल्ड द इंटरप्ट इज दॅट इन युअर obstacle you can say it is interrupt is there. So what is meant by the interrupt? See, I am taking your lecture. Okay, I am taking your lecture and suppose rain is start. So I am sitting near the window is there, and if water is coming inside my cabin is there, what I am doing? This is the interrupt. Okay, I am giving the lecture to you, and what is the interrupt is there? Water is coming from the your window to my PC is there. So what will doing? I'm doing the your lecture or close the window. So what I am doing, I'm stop your lecture for a while, maybe 1 second, 2 second, you can say that, and then close the window is there. Then this water will be stop is there. So what is the execution of program is there? My execution of program is deliver lecture to you. I am going to deliver the lecture to you, but same time some obstacles, some input is coming from the outside. So what is my priority is there? First, you have to stop this, and this is called the interrupt is there. Okay, so then go to the what is by non-maskable and maskable interrupt is there. What is meant by maskable and non-maskable? So suppose I am giving deliver a lecture to you. Okay, I am giving lecture to you, and if some students is come to me, okay, some students is come to me. If I am saying to him, I will meet afterwards. Okay, I'm not stopping my program. I'm not stopping my program. He's come to me. He requests me, sir, I want to talk to you just forward. But I'm not interrupting my because his students. I'm saying, okay, you will come afterwards. I will discuss it. But suppose some students' parents some come with me, and I'm dealing lecture to you. What I'm saying to the students, stop for a while. I want to discuss with the parents because parents are there, so they have come to the me. So I am. This is called the non-masculine because I must stop this program and attend the parent. Firstly, this is the called non-maskable interrupt is there, and maskable is then you can say that I will discuss afterwards. This is maskable, but non-maskable you must run this interrupt first and then go to the main program is there. So this is called the non-maskable interrupt is there. Understood? So where they are used is there. Suppose we are we are sitting in the theater, and if there is alarm is there, and you must open the exit is there. So you must open first is the exit door is for the outgoing is there. So this priority is non-maskable. You have to must first open the exit door. Non-maskable means what? Proper definition of non-maskable: stop the current executive program. Stop the current executive program and do the interrupt what is come to you first. First do the interrupt what is come to you, and after doing that interrupt working is there, then you go to the program is there, then you go to the main program is there. This is called the non-maskable interrupt. This is called the non-maskable interrupt is there. So trap is a non-maskable interrupt in your 805. So where how to use the non-maskable interrupt? For interrupt means what is meant by the interrupt? It is such a program is there. You have to such a program is there. You have to execute that program step by step, and you will get the output there. This is called the non-maskable interrupts are there. So trap is the one of the non-maskable interrupts, and these are the maskable interrupts are there. Okay. Next is the architecture of this 8085 is there. So these are the features. What is the main features? It is 8-bit microprocessor. You must remember data bus is 8 bits, address bus is 16 bits. Again, you have to store the memory at 64 KB is there. The accumulator is 8-bit is there, and these are the registers. Program counter and stack pointer are 16-bit. Again, you have to multiplex the database with the address bus is there, and there is the some interrupts are there. So these are the features of your 8085 there. Then go to the architectures are there. Arithmetic logic unit, register group, instruction register, decoder, control group, interrupt control group, serial input control group, address. These are the discrete diagram. So this is the architecture of your 8085. This is the architecture of your 8085 is there. Okay, so what are the parts of this 8085 is there? What are the parts of the 8085? This is one is the interrupt controller. We are discussing previously what is the interrupt controllers. 1, 2, 3, 4, 5. These are the interrupt controllers are, and this see 5 interrupt 1, 2, 3, 4, and 5, and this is called interrupt. This is called the this sixth one. Sixth one is the this one is the interrupt. A means acknowledgement. See, all the arrows are towards the interrupt controller. See, all the arrows are towards the interrupt controller, and this is the acknowledgement is from your interrupt control to the where the interrupt is coming. Where the interrupt is coming, this is the interrupt acknowledgement is there. Understood? Interrupt is given this file, and this interrupt is given to there who what is the interrupt acknowledgement is there. Okay. Then this time I'm discussing serial input and serial output. See the arrow properly. Serial input is given to the serial to controller is there, and this is serial output is come from the controller to the output. So this is the remember these things. See, this is the 8-bit internal bus. I am discussing 8-bit internal bus is there. Okay. Then this one is the instruction registers. This is the instruction decoder and machine cycle encoding. Means if you are giving the instructions to there, you have to decode this instruction first. You have to decode this instruction first. Okay. Then next is this is the register select is there. This is the multiplexer. What is meant by the multiplexer? Multiplexer means what? Same data bus and address bus act as a first address bus, and then it is act as a data bus is there. So for that purpose we have to use this multiplexer is there. Okay, these are multiplexer. So these are the temporary registers are there. B, C, D, E, F we are discussing. If it is a one pair, this is 16-bit register is there. If it is another pair is 16-bit register, it is another pair is the 16-bit register. These are the 8-bit. If you have to connect two together, it is act as a 16-bit are there. Okay. Next is the stack pointer. Next is the stack pointer is there. Next is stack pointer is there. Then another is the program counter is there. Another is the program counter is there. Okay. And then increment and decrement address are there. Next is the increment and decrement address is there. Okay. So these are the latch increment and decrement is for the purpose you have to increase the program counter is for increase and decreasing is there. Okay. But next is this is the accumulator, temper registers. This is the ALUs, the arithmetic. These are the flag registers. We're discussing flag registers. This is the flag register. This is the timing control register. This is the timing control is there. This is the X1 and X2 is there. This is the X1 and X2 is there where we have to connect the clock is there. X1 and X2 where we have to connect the clock. These are the two pins present in your 8085 where we have to connect the clocks are there. Then this is the clock out is there. Ready. Then read means you have to see the arrows. Read means you have to read the data from your controller. Write means you have to write the data in your controller. This is the ALE pin. This ALE pin it is act as for the address and latch bus are there. H0 S1 for serial input output memory, hold, HLDA, reset in, reset out. We'll discuss in lecture. This architecture is there. This is the one of the another architecture is the instruction registers. We'll discuss one by one what are the types of the architectures are there. Okay, so 5 minutes are remaining. If you have any difficulty, then tell me. For that we'll take the attendance is there. Okay, tell me any difficulty if you don't understand anything.
सर हार्डवेअर मध्ये ते दाखवा की त्याचा फोटो कसा असतो ते सॉफ्टवेअरचा
सॉफ्टवेअरचा
काय किट असेल की काहीतरी हे सगळं फंक्शन अरेंजमेंट केलं
हा म्हणजे
एखादीची
डायरेक्टली जे
किंवा
काय बोल की, हा. बोल काय म्हणतोस.
एखादी चिप किंवा रजिस्टर टाईप किंवा डायोड टाईप असं काहीतरी असेलच ना.
म्हणजे तुला चिप 8085 ची पाहायची आहे का टोटली जे किट लॅब मध्ये प्रेझेंट असतं ते बघायचं.
किटच सर
ओके
टोटल
ओके
किट
मी तुम्हाला
पाहिजे.
दाखवतो नेक्स्ट लेक्चरला ते दाखवतो मी तुम्हाला. की किटच सगळं? नेक्स्ट लेक्चरला दाखवतो मी. आता ऍक्च्युअली आता माझ्याकडे ते प्रेझेंट नाहीये आर्किटेक्चर, हे फक्त इंटरनल आर्किटेक्चर आहे. तुम्हाला मी डायरेक्टली ते किट होतं, पीपीटी मध्ये ते किट नाहीये. मी तुम्हाला दाखवतो किट कसं वर्क होतं आणि किट मध्ये काय काय असतं ते. अजून काय? अजून एनी क्वेश्चन्स? बोला अजून काय तुम्हाला काय समजलं नाही? अजून ते किट मी पुढच्या वेळेस दाखवतो. अजून काय? Any difficulty regarding this lecture? जस्ट आपल्या रेकॉर्डिंग कशासाठी केलं की आपल्याला माहिती असो कोण प्रेझेंट आहे कोण नाही, बाकी काय उद्देश नाही. हा, ठीक आहे. बाकी सांगा मला अजून काय. हे तर इंटरनल स्ट्रक्चर आहे, ते बाकी दाखवतो मी तुम्हाला. ते स्ट्रक्चर मध्ये काय आहे ते.